I'm Paweł, hi everyone. I'm coming from Dialogue System Group from the other place. And I'm going to talk about dialogue, building conversational AI. That works hopefully overnight, which is in 24 hours. So just to get good estimates about audience here, who has heard about Amazon Alexa, Google Home, or yeah, everyone, okay. Who has been using it on a daily basis? Yeah, huge drop. And I know the reason why, because the system sucks.
Alexa,
this is a good example of it.
How are you feeling?
I'm doing great. Did you know cats sometimes talk to me when there's
Alexa,
nobody else around?
How are you actually feeling?
Sorry, I'm not sure.
Right, so I just add one simple word to exactly the same question, trying to be a little bit more emotional, and Alexa is broken. So 3,000 engineers in Seattle cannot really actually answer this super simple question. So the natural question that shows up here is why it doesn't work. And I would love to give you a full explanation. But in reality, the answer is super simple because it's hard. And why it's hard? So we're going to be talking about spoken dialogue systems, and this is highly modular system that consists of many small pieces. So let's say analyze the problem, for example, when you're going to talk to Siri and going to say that we need to book a taxi to a specific place in town, right? So first we need to transform speech form, waveform to something that is text. That's been done by speech recognition system. Then we need to use some language understanding to map the text to something that is meaningful to the system. For example, information that we are looking for service taxi to a specific destination in London. Then we have to make the decision what we're going to do next, which we're going to call a dialogue management problem. And that often involves third parties APIs like knowledge bases, Wikipedia to answer all your problems. And then finally, well, not even finally, we need to map this internal semantics to something that is representable in normal text, and hopefully also make it, again, in the waveform to have a natural conversation between the system and the user. So we see there's a lot of pieces here, and every time one of these pieces fail, then the whole system fail, and then you guys not using the Siri anymore, right? This is essentially what happened in the last decade. So another natural question is, how do we actually train all these bricks together, right? So in machine learning field, usually that means that we need data, and a lot of data. And thankfully, I'm going to be talking about that a little bit later, but in last decade, that wasn't that obvious how to gather this data, where to get money, or basically how to do it. So in my lab, people came up with this crazy idea that why not just let the system to learn on its own how to talk to you. We're going to first start with this approach. So in AI kind of environment, we call it reinforcement learning. That's going to be, I believe, so also a huge topic for next speaker. So I'm just going to give you a brief idea here. So why not just copy how the toddlers are learning, normal human beings, right, when they're super small? But instead of having normal brain, we're going to have artificial neural network. That's what is sexy nowadays. So this is our agents that's going to learn how to interact with the world outside there. So of course, we're going to give him an ability to make some decisions, what we're going to say next. It doesn't have to be real language for now, but let's assume that it is. Because we are having conversation with the word, we're going to get back some observations, right? And at the end of the dialogue, or maybe during the dialogue, we're going to get some reward. By reward, I mean any signal where the human being is happy or not happy about the conversation, either shouting or giving 5 stars to your app because you know how to book a good pizza, a good restaurant for the user, right? So super simple and general approach, and this has been a big thing in the AI community in the last couple of years. So we decided to train our model to learn how to find you a best pizza restaurant. So let's say we have 100 restaurants in Cambridge. This is our problem setup. We're going to have a couple of requirements that the user would like to have, for example, a type of cuisine, the price, area, and the city. And the system we require the system to learn how to talk, how to provide the right restaurant, give the right information, how to get there at the end of the day. So in previous years, we actually managed to learn how to talk to the human being, starting completely from scratch with direct interaction with real users through speech. And that was a huge thing. So looking at this plot, you see that along with training dialogues with real users, we're getting better and better at success rate. But is what also very symptomatic here is this wiggling thing. And in general, the problem with neural network is that they tend to overfit to the data. They tend to really believe what they see in the data, and they're trying to optimize that for that course. So in one of my works, I decided to use another buzzword that is very popular right now, which is the uncertainty about AI, which in machine learning field, we call it an Bayesian approach. And in this case, we're trying to put some probabilities over your decision space, so that when you're about to ask the next question to the user, you first ask yourself how confident you feel about that. So what we would like to see in this graph is that we would be less wiggly about learning this curve, because we are more, we are not that going for crazy actions, and also because we have some probabilities, we can be more wiser how to learn faster. And this indeed helped us improve the learning speed and also how does the system behave. Now, someone might say, okay, we're done here. We just let the system talk to real users, and for next 50 years, it will eventually pass the Turing test. Well, reality doesn't sound that nice. Let's have a look.
Hello, welcome to the Cambridge Dialogue System. How may I help you?
Restaurant?
What part of town do you have in mind?
West. 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 West.
Would you like something in the cheap, moderate, or expensive price range?
Yeah, that's not the most pleasurable experience that we ask people to have with our system, especially in the beginning of learning. And you can imagine that we're gonna show up at the VP of Alexa or Siri. I'm gonna show this example. He's probably not gonna let you learn with the users how to talk, right? So let's go back to the first thing that is the most common approach in the AI community is to learning first your system on the data, and then maybe fine-tune with reinforcement learning, right? And I know that that might sound super crazy, actually, but when it comes to conversational stuff, we don't have that much data as any other fields, like, for example, perception. And that sounds super crazy because basically internet is full of our conversation on any topics. But what I mean by data is something that is specific for a domain, like finding a restaurant for you, and it's labeled in the way that system can learn from this data, not just pure text. So the other work where we are thinking about to do over the last 2 years was to find a way how to find this data pretty cheaply without putting the burden on us experts in NLP to annotate this data, and at the same time provide this data set to the community. Because what happens nowadays is that Alexa or, for example, Siri has billions of communications every day, while and at the research community we have really small data sets. So we came up with this Wizard of Oz setup where you have the user who's given a task that he needs to fulfill, for example, find the best hotel in London. We also have a system, another human being, that is given graphical user interface that he can interact with. And we put the, artificial wall between them too, saying to the user that the wizard is actually real, for example, Siri, not telling them this is actually human being. We are trying to keep track of everything they do in the chat room. And then in that case, we are getting all the text plus the labels that we really need to train our systems. What is also super important here is that we can do it in a synchronous way. So I can start gathering data over 1,000 dialogues, going to Amazon MTurks, pay a little bit of money to people from all over the world, and get 1,000 dialogues within a couple of hours. So this approach enabled us to create really nice and complex and really big data set above 10,000 dialogues. That is the largest so far in the world. They are super important is to have natural conversation, and this is exactly what we're getting from this setup. And through our already evaluation, and we arrived at the conclusion that it really creates new challenges to the community in terms of dialogue modeling. Now, this slide was, I think it's still actual, it's still on, but I know already that, for example, Google decided to go for not 10,000 dialogues, but 2 million dialogues. So yeah, I'm just happy that I still claim that's the largest one, not too far along. All right, let's go back to the idea of training this conversational AI overnight, and let's put the bricks together. So we have a way to actually gather data very fast and very cheap through Amazon MTurk and Wizard of Oz setup. So what we can do, we can put the neural networks on top of this data that I did not talk about much here, but what we literally what we're going to do here is we're going to bootstrap our system based on this data, and then, only then, we can go back to the idea of letting the system then interact with the real world and getting better and better with, along with the time, going from one domain to the other, and hopefully in 50 years we will be able to pass the Turing test, which is the holy grail, at least in our community. And then basically you can do it in 24 hours. You can start talking about, well, at least restaurants in Cambridge. All right, that will be all. Thanks, and let me know if you have any questions.